So this is a problem on an inclined plane wherein the block is resting on it, and we need to find the minimum force P acting in upward direction that will cause the motion of this block to start in the upward direction. So since the motion itself is happening in upward direction, so friction will be acting opposite to this. Fine. Of course, there will be a vertically downward force, that is W, the weight, and there will be a normal reaction here at the surface, that is N. So this is the normal reaction. Friction is mu times N. This is the force that we're supposed to find, and this is the weight of the block. So now in the question some data is given. You can see W has been given as 295, so that value we have to use here. Alpha value, that is the angle of inclination here, that's given as 43 degrees with the horizontal. And then coefficient of friction, the coefficient of friction, that is mu, that has been given here as 0.33. So each student will be given a different value of these W, alpha as well as mu, and those values you need to use in order to find this unknown, whatever it is that is asking. So let's go ahead and take these values and solve it. So whatever angle alpha is there over here, the same angle will appear over there. And for our problem, we'll be taking x and y as the reference axis, x axis and y axis. These axes we'll use as a reference. Let's go ahead and start solving it. So first we will take sigma y, summation of all the components in y direction. Now n is acting upwards, mu n is perpendicular to y axis, so it will not have any effect in the y direction. Same is the case with p. Let's take the other forces. We have a component of w, the cos component, that is acting downwards. So this total has to be equal to 0 because the object, the block, is still in equilibrium. So that's equal to n minus w, the value of which is 295, cos alpha, the value of which is 43 degrees. So now if you solve this equation, we will get the value of n as 295 cos 43. Let's do the calculation for this. So 295 times cos 43, so we're getting 215.75 newtons. So this is the normal reaction that we're getting over here. Now using this normal reaction, we'll have to go for the next step, that is summation of all the components in x direction. Now p is acting parallel to x in the positive direction, so hence this is positive p. Then friction is opposing it, so minus mu n will act over here, and a component of w will also act in negative x direction, hence we'll have to take that as well as negative. So that will be minus w sine alpha. Now let us substitute all the values. Sigma x has to be 0 because it is inside equilibrium. P is not known and is yet to be found. Mu value is 0.33. N value we just now found, that is 215.75, minus W value is given here, 295, and sine alpha, alpha being 43 degrees. So let us substitute all this, and here you can see P is the only unknown, so we need to find it. So when we send these terms to the other side, they become positive. That's 0.33 times 215.75 plus 295 into sine 43. Let's do these calculations over here. 0.33 times 215.75, and then we need to add 295 into sine 43. So that's giving us 272.39 newtons. So this is the value of P that we need to substitute. Let's substitute and submit it to 72.39. Submit, finish. And there we go. This is exactly the value that is calculated by Moodle as well. So when you're solving as a student this problem on the Moodle, you will get different values. So don't try to feed the same answer over here. Some students are going to want to do that. It will not accept that. Fine. So depending on what are the values given, you'll have to take them, then do the calculations to arrive at the answer. That answer is what you need to feed here. Thank you for watching this video. In the next one, we'll take up another problem.